In this video, I'm going to give you an update on how the testing portion of this project was conducted and go through any changes or updates made to my circuit. My project is the fridge monitoring system, which alerts the user through Bluetooth if the fridge's temperature is too high or too low, or if the fridge door is left open. Shown here on the screen is my new circuit, which was converted over to the prototyping board. All connections originally on the breadboard were transferred to this board and were soldered into place. This creates a much more solid and secure design, eliminating error caused due to loose connections or components slipping out of place. This was something I was encountering for my previous submissions. Before we get into any tests that were actually conducted, here is my circuit just inside of the mini fridge. Now on to our first test. Here the phone is notifying us that the door is closed. We know this is true by the position of the door entry sensor. In this clip, we see the door is left open. The notification on our phone confirms that this is indeed true. Now, after closing the fridge door, we get the updated notification on our phone that this action was successfully completed. In this freeze frame, we see the varying temperatures measured by the temperature sensor that are being sent to the phone. These fluctuations are due to the constant open and closing of the fridge door during testing, meaning that the room temperature air is constantly entering the fridge and causing the temperature measured inside the fridge to rise and fall. Due to challenges I was facing with my previous temperature sensor, I upgraded to the TMP36, which has been performing significantly better for the scope of my project. I'm very happy I made this switch. It has made testing go very smoothly. Like my last sensor, it has 3 connections: a ground, a power, and an analog connection, which I've plugged into port A5 on my Arduino. I've included this clip to show you that as that temperature continues to drop and we get below our threshold of 5 degrees, that notification that the temperature is too high comes to an end. Here we see the temperatures in that threshold of 2 to 5 degrees. Now we're opening the door just to see how the temperature is going to respond. And like expected, we see that start to climb back up again. We also get that notification that the door has been left open. In this clip, I did a slow sweep over my entire circuit to show how all components have been incorporated together and connected on the prototyping board. Please notice the new resistor connected in series with my magnetic door entry sensor. This resistor has been placed to protect the Arduino. We can also see the newly integrated TMP36 temperature sensor, and as mentioned before, it is plugged into port A5 of the Arduino. Here's a close-up of the new pull-up resistor. It's connected between the 5-volt rail and the common node connection. This node is connected to the magnetic door entry sensor and digital port 4 on my Arduino. As noted in my progress update, I was unsuccessful in finding a new app to implement in the time frame before the submission. However, I will continue my search in hopes of finding a better one for the next deadline. I apologize for this, however, since this submission was just to confirm that my design still worked after switching to the prototyping board, I decided to focus on this aspect. Thank you for watching.